Hey everybody, MS Farzan here, and welcome to part 3 of making a 2D card game using Unity. In this video, and I should say in this video and the next video, we're going to be working on adding multiplayer functionality to our 2D card game. If you haven't already worked through the first two tutorials in this series, part 1 and part 2, I highly recommend going and checking them out, as you'll understand better what we're going to do here and why we're doing what we're doing. But I'll also include the original GitHub for this project right here where we're about to start. So if you just want to install all of that stuff and get working here, you could do that as well. I'll give a quick run through of the code so far so that you have an idea of where we're at. And I'll also post the updated GitHub of everything that we will have done by the end of this video and the next one. It's going to take about 2 videos to get through all the multiplayer stuff because there's a lot to cover and a lot to do. I'll also recommend a couple of articles and video series that you'll want to look at to brush up on networking. And we'll be using specifically a package called Mirror, which aims to offer a multiplayer solution for Unity, as there's no native solution for multiplayer in Unity as of this time, as of the recording of this video. I'll talk about that a little bit as well. So we're looking at our game screen, and I'm just going to give you a quick run through of where we are. We have a very basic 2D card game that uses the Unity canvas to deal cards and allow us to drag and drop them around. When I hit play, we'll see that functionality in action. I have this button that when I hover over it and click it, it draws cards at random from a list that we'll look at in the code. And I have a random assortment of red and green cards. When I put my mouse over one of the cards, it sort of highlights them. It expands them so that I can see, let's say, the text on them better if I have text on my cards. And when I drag one over this drop zone here in the middle, it's going to automatically add that card to the drop zone, which itself is a grid, and it has this really nice feeling that I'm dragging a card and dropping it in a drop zone, and then the drop zone is handling the representation of that card as it's in the drop zone, just like that. To get there, well, it's taken us 2 videos to get there, and some of the reason why is because we've had to work with the Unity canvas, creating these game objects here. We have a background, a drop zone, a player area, and an enemy area that are represented here on screen in the user interface. There's the button that has a little text element on it. And of course, all of these are nested within the main canvas. And we have most of these things saved as prefabs so that we can use them over and over again. And we also have 3 scripts that handle all of the functionality that we've seen here. One of the main ones is this draw cards script that I'll open here using Visual Studio. And these 3 scripts are essential to what we're doing here in our card game, and will be essential to our multiplayer as well, and we'll be editing them heavily, which is why I've created a new branch on the GitHub for this project specifically for multiplayer, just to have a clean separation of our code, because there's going to be a lot of changes that we're going to do here. Just reminding you, or welcoming you if this is your first time watching these videos, to what we've been doing. We have a draw cards class that derives from monobehavior, and we've exposed these 4 things, these 4 public game objects in the inspector. One of them is card 1 and card 2. We also have a player area and an enemy area. And let me just show you that in the inspector. So this draw cards script, it lives on this button, which is called draw cards. If I click on that button, I see that I have the draw card script attached to it. And what I've done here is I've dragged and dropped the card 1 and card 2 prefabs into these open fields from these public game objects that we've declared. And the player area and enemy area that exist here, the actual objects, because these will be instantiated at runtime. We've created a list called cards that holds game objects, and that when this button is instantiated, we use a start function to add card 1 and card 2 to that cards list. And then when someone clicks on the button, we run a for loop. In fact, instead of this being a variable, let me just change this for my OCD to say this is going to be an integer. We count to 5, and at each count, we instantiate a random card from the cards game list, the cards game object list, and we set the parent of its transform to the player area. And we do the same with our enemy cards. We instantiate 5 of them at random from the list, and we set the parent of the transform to the enemy area. If you don't understand this quite a bit, I just recommend checking out those first 2 videos, as we'll walk through the each step of how to do these things and why we do them. But what happens is we've added an on-click function here, where there's an event, I should say, that when someone clicks on this button, we tell Unity that it should call the drawcards.onClick function, which is what we just saw here. This is called onClick, and that's what it's drawing from when somebody clicks the button. Additionally, we have this drag and drop script, which is a little bit convoluted just because of the way that dragging and dropping works in Unity. I'm not going to talk about this too much because we won't touch it very much, just a little bit in our multiplayer tutorial. But suffice it to say that we figure out where the canvas is when the game object this is attached to, which will be a card. When it comes awake, it finds the main canvas, and we do some work to see if the pointer is over the object or the card, and when someone clicks on the, or I should say when someone clicks on the object, when someone clicks on the card, we set the this Boolean up here is dragging to true, and we tell Unity to essentially attach the card to the pointer, to the mouse pointer, so that it moves wherever the mouse goes. And whenever it is dropped, if it's dropped over a drop zone, and we've used colliders to determine whether there's a collision between this card and the drop zone, then we say, okay, go ahead and drop it in the drop zone. But if it's not dropped in a drop zone, return it to its original position. And we've also done some work to make sure that it's parented as a child of the canvas, so that it stays in front. I'll just show you this right here. When I drag something, we were seeing an issue in the very first tutorial where I would drag this and it would go behind the draw cards button, or it would go behind the enemy area or behind the player area or whatever. And we just, if you can watch on the left side of the screen, when we do this and I drag the this card, it's actually becoming a child of the main canvas, so that it stays on top of everything. And notice when I try and drag it somewhere that's not a drop zone, it just goes back to its starting position. But if I drag it over the drop zone, it detects a collision, and that allows it to be droppable. We've also had to do some work with the layers of the game, so that we determine what layers are collidable. If you're interested in that, please go ahead and check out the code, as you'll see, or check out the project, as you'll see all of that in there. And finally, in this card zoom script, that's the one that we use to create a larger version of the card on mouse over, and we're just saying on hover enter, when the mouse hovers over this thing, create a new game object that's twice the size of it, and when we zoom away from it on hover exit, just delete that new version of the card. Taking a quick look at the prefab, we'll see all of this in action. So we have the 2 scripts that are attached to it. We have the event triggers that when a drag starts, we should do the start drag function in our script. When the drag ends, we should end that function, or we should use the end drag function when hovers happen, or when the mouse exits a hover, we should do something. And then we also have a box collider and a rigid body attached to this so that we can work with the drop zone. I should also mention that we have for our initial tutorials, we've just been using a basic image with no sprite attached to it. We've just been using green and red cards. So as you've seen, when I draw cards, I just see red and green cards. The only thing that I've done in between then and now that you're welcome to keep going the way that we have, or to add your own sprites if you have your own cards that you're working with. But if you check the GitHub for this project, you'll see the assets for this particular tutorial are in the assets/assets folder. They're just cards from my own card game, which is called Entromancy Hacker Battles. I'm going to be playing a little bit with, perhaps not in this video, but in the next one, the backs and fronts of cards, so that if I'm looking at enemy cards, I can only see the backs of those cards, whereas if I'm looking at my cards, I can see the fronts of them, and vice versa. So what I'm going to do here is I've added those assets in the assets/assets folder, and I'm going to grab my card 1 prefab, and instead of there being no source image here, I'm going to say here that it's this cyan underscore ping at 3x sprite. Again, it could be whatever sprite that you like. That just means also that I need to change the color of this to white, so that there's no like color overlay, or I don't want to mess with that at all. And then for my other prefab, card 2, I'm going to go in here and I'm going to change the source image. As you see, there was none, and we had that red color instead. I'm going to change that to the magenta version of this card, magenta ping, just so we have a little bit of variation. I've changed the color to nothing, just white. And then now when I hit play and I hit draw cards, now I see it's still randomizing my cards, but now I'm seeing card 1, rather than being a green card, it's this blue card, and card 2 is a magenta card. And then, this helps me a little bit better. I still, have a little bit of work to do if I want to do this hover over thing, but because it's not really working appropriately here. But in any case, that's the functionality that I want to see. Okay, cool. So we're all caught up and we know everything. Great. So let's talk a little bit about multiplayer. As this has been a topic of contention for me, as I've been looking for a multiplayer solution for a very long time for Unity. Whereas in JavaScript, for example, I have another video up about doing a multiplayer card game using Phaser as the game engine and Socket.io with Express as the backend doing the multiplayer. Unity, I don't know all the reasons for this. There's a blog post out there that's been posted by Unity that they've deprecated Unet, which was the native multiplayer solution that they had prior to this time. They have deprecated, or they are deprecating it, and the solution does not exist publicly yet. I'm not sure what they plan to do for multiplayer, but there currently doesn't exist a viable solution that's put out by Unity for multiplayer, which is kind of crazy to me, but whatever. I don't make up the rules. So what that means is you have to go out and find your own solution, a third-party solution to do your multiplayer, which to me isn't ideal because I don't know how supported it is or how it interfaces with Unity. And I've done a bit of research to figure out what's out there. And you have a few options. You have Mirror, which is what we're going to use today. You also have Photon. Photon has a Unity-specific networking solution called Pun, P-U-N, that you can look into. I looked into it to myself. It's a little bit more than what I need for this simple card game. And there's also like Fox Server and a bunch of other things that you can just do a search for multiplayer Unity, and you'll find more than you'll ever want to know. The reason why I chose Mirror is it seems to be the most streamlined and easiest to use of all of the different frameworks that are out there, at least to my knowledge. It also is, I think it's actually a fork of Unet, so it shares a lot of similarities with Unet, meaning that Unet has a lot of official documentation that has been deprecated and isn't necessarily exact an exact copy of what Mirror offers, but if you get stuck using Mirror, you can look up some of the unit documentation, and it might not be exactly analogous to what you need, but it might also provide a breadcrumb for you to figure out what direction you should be headed in to find a solution to your problem. I've definitely had that experience in this project, but hopefully you won't have any problems and it'll all work out. Cool. So before we get into the actual doing of the multiplayer aspect of this card game, I'd like to walk you through a few things about why we're doing the things we're doing, and establish some terminology as well, because the networking aspect, at least in my experience, is completely different from most of the things you've already encountered in your Unity career so far. Some of the terminology is different, some of the ideas and the concepts are different, and it would just be a great idea to familiarize yourself with these concepts before we tackle the game itself. We're going to do some explanation while we're in the game, of course, but I would highly recommend that you check out two things before let's say three things before we even get started. If you want to just jump in with me, that's fine too, but it would really be helpful to do three things. Go to mirror-networking.com and just look through the documentation about what it does and what you should expect when you're using Mirror, and what are some of the best practices when doing so. I'll talk about these in great depth some of them in great depth while we're cracking through our code, but it would be a great primer for you as a developer just venturing into the multiplayer sphere to be familiar with some of these concepts. The second is this very cool article on Game Dev Academy on how to create a multiplayer game in Unity. This particular tutorial is made using UNet. It uses Mirror. Yet some of the things that they discuss in it are not exactly the way that UNet works now. I don't know if it's been updated or it's not. I'm not even sure if you ran through this entire tutorial, if you'd get exactly where the authors of the article want you to get to. It's not impossible, of course, but it runs you through some ideas about what the network manager does, how to spawn items on screen, what the player object does, how to use a sync variable. And even if you just read through it, I think it will give you an idea of how Mirror works and why you should be using it. It doesn't work perfectly for our purposes, which is why I've had to create my own solution for this, simply because it operates on the idea that you, the player, are an object in the scene. You're this like little spaceship and you're trying to fire at enemies, which is not what we're doing at all. We're as players, we're actually removed from all the game objects because we want to drag and drop them all over the screen. So it requires a bit of a different approach. But in terms of a basic entry point to Mirror and understanding how it works, this is a great article. I'll link it in the description for this video. And First Gear Games has a wonderful tutorial series on YouTube, which I'll also link in the description for this video, called Unity Multiplayer with Mirror. It's like, 11 videos, 12, 13, 14 videos. You don't have to watch all of them, but I found them to be really helpful resources in understanding the API that is available to you. I should say that the Mirror Discord community also has been very helpful, which is where I found out about these videos. So if you have problems, check out this video series. Definitely look at the Mirror documentation and visit the Mirror Discord because they're very helpful over there. Cool. Great. All that's out of the way. Let's talk about what we're doing here. So in Mirror and in other paradigms of multiplayer networking, we're going to presume that we're going to have two players that are entering this two-player card game. On the one hand, one player is going to be a client, just a standalone client that is going to attempt to connect through the network to play a game on a server. That's the general architecture of how things work. The other player is not only going to be a client, but they're also going to be running the server. in a peer-to-peer networking situation. So if you're playing, let's say you're playing as the client, and I'm also playing, I'm going to be a client too, but we need to host the game somewhere. So I'm going to be the server and the client at the same time. And that makes me what's called a host. So we're going to use those terms over the course of these next two videos, saying that I'm the host, meaning that I'm the server and a client, and you also are going to be a client, but you're not a server. So in some ways, I'm fulfilling two functions, or my computer is fulfilling two functions, whereas your computer is just being a client. That is going to take us into the wide world of authority, which is something that might make you bang your head against the wall, as it has mine. But once you understand it, it will help smooth a lot of the rough edges of attempting to get a game up and running with Mirror in Unity. If I have authority over an object, that means that I can do certain things with it based on networking. Oftentimes, the server has authority over everything. So if we ask the server, for example, make us a bunch of cards, the server will have authority over it. And if I'm playing as a host, remember, I'm also playing as the server, so that means that I might have authority over those cards. But if I ask the server to spawn a bunch of cards on both of our screens, then you might have a bunch of cards on your screen, and you might say, well, okay, I want to do some networking stuff with it. And unfortunately, you won't be able to do anything with them networking-wise, because you don't have authority over those objects. That's one concept that we'll return to time and again throughout the tutorial, and it's worth looking through this documentation to understand the authority aspect, as well as local players, whether or not you're the local player or whether or not you're the server or the client. Those are a few different things that we'll, like I said, encounter time and time again. And it would be worth just looking over this documentation and getting a general idea before we dive in. So a lot of this we'll encounter as we get through the code. So what we'll do, you and I together, we'll go to the asset store. And you're going to want to search for mirror networking. I already have it in my saved assets, so that shouldn't be a problem. And what we need to do is we need to import mirror. So I'm just going to my assets here, and one of them is mirror. I'm going to download that. If you don't have it here, obviously that's because you haven't searched for it. So go ahead and search for it in your in-game asset store. And then after it's downloaded, I'm going to click import. It's going to prepare a package for me. And when this dialog box jumps up, I just want to make sure everything's selected. I'll click import. It'll go ahead and do that. And I'll notice in my project pane down here that I'll have a new folder called Mirror. And we'll look through some of those things that are available in there for you, although we won't really touch any of them. We're just going to be using the functionality that comes along with that package. Something else to notice is that I'll be using the word spawn, which is what Mirror uses to indicate what we usually say instantiate a game object. In Mirror, when you instantiate something, that's all well and good, but if you want the server to handle it and to create it so for everyone to see and to play with, you have to spawn it. So you might hear me say spawn, and don't want you to be thrown off if you're used to hearing instantiate. So you see here on the left-hand side of the screen, I have a new mirror folder in the assets folder. Just taking a look at that, I have an authenticators folder, compiler symbols, components, editor, examples, icon, plugins, and runtime. You can look over this at your leisure. The only thing I want to point out to you is if you go to the examples folder, you'll see several different examples of how to do stuff in Mirror. For example, if you need a chat service, you can check out the chat example. If you want to look at Pong, that's a great idea. There's a Tanks example that has a very simple Tanks game that's not too dissimilar from the way that that tutorial that I showed you earlier on Game Dev Academy works. So check those out if you get stuck or you just want to kind of grok what Mirror does. Otherwise, the whole thing starts when now that we've installed Mirror, The whole thing starts when we add an empty game object on our screen. And we're going to call this Network Manager. So empty game object just on our scene. And we're going to add a component to it, which is called a Network Manager. This Network Manager is what's going to allow us to do all of our networking for our multiplayer game. I think there are ways for you to create your own custom network manager and do a bunch of stuff by digging into the specific code for the network manager. We're not going to do any of that in our game development. We're just going to use what comes out of the box for most of this stuff. But just there's a whole world awaits if you're interested in it. The two things that are important here that we want to look at are the player prefab area and the registered spawnable prefabs. Mirror presupposes that you have a player in your game that is going to do most of the actions in your game and is going to have the authority to do those actions. If you think about like a tank style game or that Space Invaders type game that we looked at with the tutorial, if I'm like a spaceship, that's going to be my player prefab, and that player prefab is going to do stuff like create bullets and do damage to enemies and all that stuff. We don't have that particular situation here because we don't really have a player. I'm the player and you're the player, but we don't have a representation of us on the screen. So it's going to be a little bit different the way we handle this. But still, we're going to have to create a player prefab and drag it to this player prefab field. And anything that we want to be spawnable in the world, for example, if we want to be able to spawn enemies or bullets or elves or anything, that needs to be in this list, and we'll add our cards to this list. So what I think we should actually do first is add one other component so we can see what's going to happen. We're going to add the Network Manager HUD or heads up display right here. And that allows us to do to see the Network Manager in action when we play a game. As you can see, there's a telepathy transport script here that is working with port 7777. So when the game starts, it's going to start listening at that. The server is going to listen at that port. So when I hit play, now before where we didn't have anything here, now we have this nice little heads-up display that is this we would use for development purposes only. Obviously, as a in production, we might use some other sort of solution or change things so that it looks differently. But I can choose whether I'm going to be the host, where we said that I'm a client and a server, whether I'm going to be the client, or if I just want to be a server only, which is also an option that we won't be doing this. We won't be creating our code in that fashion. We're going to be presuming that one person is going to be the host and the other person is just going to be a standalone client. But you could just create a server and have people log into that server and handle your game architecture differently than we're going to do here. But if I click host now, it says server active, transport telepathy server port 7777, and the client address is the local host. That just means that it's listening on 7777 and for a client to attach to it. That's not going to happen until I have another client to attach to it, so nothing's going to happen here. So I click stop just to show you if I hit client, it's going to say connecting to local host, but there's no server anymore because I stopped the server and it's just going to stop its operation because nothing's happening. So that's going to be the general workflow that we'll have. Cool. So we've created our network manager. Before we do anything else, let's create an empty player object. Let's call this the player manager. And as I mentioned, well, let's do a few different things. Let's close our mirror folder. Let's go to our prefabs and let's create prefabs of a few different things. Let's create a prefab of my player manager. Let's create a prefab of this button. And what else can we do? Let's make sure that the prefabs that are exist for our background and the drop zone and the player area and enemy area, they don't have any overrides, meaning that we haven't made any changes to these objects here that need to be applied to the prefabs. Okay, great. Now that we've done that, we have all our prefabs here. Let's go to this to our network manager, and under the player prefab area field, let's drag that player manager. We'll say that's going to be our player. That's going to represent us in the game. And we see that we get an error that network manager player prefab must have a network identity. And that's a great segue into talking about now we have our network manager, but we also need to indicate to Unity, or specifically to Mirror, which of the game objects that we are using in this scene, which of them are things that we want to take network actions on. The background is going to be the same for every player that joins this game. But as an example, so I don't need to add a network identity to it, but my players do. If I'm thinking that I want to do network actions with this player, well, then I need to have I need to attach what's called a network identity to it, so that a mirror can perform network operations on it, or network actions. So I'm just going to add a component called network identity. And you'll see it just adds a basic script here, and it has a check mark to say whether or not it's server only. We won't be using that because we want our players to be both on both clients. And we'll also add another component here, which is called a network transform. I'm not actually sure that this is necessary for your player object if we're not actually having a representation of the player in the screen. A network transform is used, or the component, the script, is used to determine where your game object is on the screen, so that it can sync it up between my client and your client. The server does that. And since we don't have a representation for it, I'm not sure that it's actually necessary for your player object, but who knows? I actually haven't tested that, so it doesn't really make that much difference. I can delete this from my scene because I don't need it. I'm going to instantiate it at runtime. And what I'll do now is I'll go back to my network manager, and I'll drag the player manager to the player prefab. And what did I do wrong? Oh, I did exactly what I said that we shouldn't do, which is I added that I added all that stuff to the object and not to the player manager itself. So here's a cheat. If I just say network transform, it will add the network transform and also the network identity to it in one fell swoop, so I don't have to do all that again. Back to my network manager, dragging my player manager to the player prefab, and there it is. And I'm also going to add a few other things to the network manager. And these are the things that I want the network or the server to be able to interact with over the course of my game. And we'll see. I'm going to save you some time from having to search to understand which ones are going to be needed to be managed by the server and which ones are just going to live on your screen. And just tell you that I need to add my cards, I need to add my button, my player area, my enemy area, and my drop zone. So I'm just going to add all those here. What did I say? Those are 6 items. So I've got 2, 3, 4, 5, 6 things. And to each of these things on card 1, I need to add a new component. And I'm just going to add the network transform. Remember, that's going to add the network identity and the network transform here. While I'm doing this, I'm also going to click on client authority. If I hover over this text, it just gives me a tooltip that says set to true if moves come from owner client, set to false if moves always come from server. That just means that I want the client to be able to have authority over this object rather than saying the server's only ever going to do the work. I go to card 2 and I add a new component. I add that network transform, which also adds a network identity. I click client authority. Now I go over to my drop zone and I do the same here. I'm going to add a network transform. And in this one, I'm not going to click client authority. We'll see why in a bit, but just to explain it here, the players never actually do anything with the transform or the position of the drop zone. They are going to move things to the drop zone, but the server is going to handle everything else that has to do with the drop zone. So I don't need the client to have authority over it. It's not like I'm moving my drop zone around with my as a player. And that goes the same for the enemy area and the player area. I've added a network transform to both of them. Now I go back to my network manager and I'm just going to drag my card 1, my card 2, my drop zone, my enemy area, my player area, and we need to do our button as well. Where are you, button? Network manager, add the button. Great. Now this just means that my network manager is prepared to spawn these prefabs when necessary, either through scripts or when I ask it to or whatever. And it has my player manager as the player prefab. When I hit play, what you'll see is that there's nothing really going on in my screen until I click host, and then all this stuff is instantiated as it should do. You might be scared when you first hit play and you're just like, wait a minute, where did all this stuff go? But rest assured that it's all just, it's all still here. It's just that now that we've given the server or mirror control over it, it instantiates it at runtime rather than when you hit play. So when I hit host, it comes back on and I have the same functionality that I did before. Okay, that's a good time to go get a drink of water or whatever you need to do, because we're going to start talking about code. If I looked at my original scripts, I just have these 3 basic scripts that we talked about at the beginning of the video. And I'm going to need to do quite a bit of work to make it so that when I am playing the game and you are playing the game, we're able to communicate among each other. And I think this is actually a really great time to demonstrate what your workflow is going to be like when working with Unity and Mirror in a networking situation. If you haven't done any multiplayer in Unity, which I hadn't before taking on this project, it might come as a surprise to you that you're not able to just do everything from the comfort of your Unity editor as you have been able to. Because you need to run 2 executables, so to speak, you need to run 2 games, what I need to do is I need to build the game and actually run it every time I want to attempt to do some networking. Because right now, I only have 1 client here that's also operating as a server. It's a host. To create another client, I need to actually build it, I need to make the game and run them both simultaneously so that they can communicate with one another. The way that I'm going to do that is I'm going to go to File, Build Settings, make sure that my sample scene is included in the scene, and I'm going to hit Build and Run. And it's going to require me to create a folder. I'm just going to call it, let me create a folder here called Build. And I'll use that folder to build. And then it'll take some time to do that. So this might lengthen the video time of this video because we're going to wait for it to build every time that it does that. And you'll see if there's some sort of error, it'll throw you an error. Oftentimes, if you still have the game running, it'll throw you an error. So just make sure you've closed whatever game you've already built. I'll show you what that looks like. But it goes ahead and because we said build and run, it will build the game and then immediately run it. And we'll see that I'm now at the same screen as I was before. When I click on LAN host, it starts the game. I can just allow access here. It starts the game, and I have the same functionality here as I did before. But when I go back to my editor, if I hit play, remember how we hit after we did this, we hit client and nothing happened. Well, now I'll hit client and you'll see the client is pointing to the local host. It starts the game because it's connected to the server, or the game that's running out here is it's playing. We've selected it to be the host, so it has provided a host for our editor to connect to, and now we have these two games playing in tandem. I can draw cards here. I have the same thing happening as I have on my built game. And let me just stop these processes and switch it around so you can see what's happening. In the editor, I'm going to say I want to be the host in the editor. Remember, that means I'm going to be a server and a client. And if I go to the console, I see that I'm thanked for using Mirror. It lets me know that the telepathy transport is initialized and that it's listening on port 7777. And it says start host client called. So we just means that the host client has started. And then in the built version of the game, I hit client, and the same thing happens as before. It just starts the game, and I'm not really getting any logs here, so it doesn't really tell me anything. But what I want you to know is that these two games are now communicating with one another over localhost, but they don't know anything about each other because we haven't told them to do anything in terms of networking. So nothing will work. But it is successfully. They are successfully communicating with one another right now, and that's cool. So I'm going to make sure to hit Alt F4 to close this this game window. If I don't, and I try to build the game again, I'll get an error. Stop the game from playing. And next time we do this, rather than going to File, Build, Settings, all that, I'm just going to hit Control B, which is going to build and run my game, save you a little bit of time. And then we're going to do that every time we make a change to the code that we want to test. Super annoying, but it's just what you got to do to make it work. Okay, great. The first thing we're going to do is we're going to figure out how to change the onus of this draw cards function, change the functionality of it so that it doesn't just happen on my screen, that when I click it, it's going to ask the server to spawn those cards so that everyone eventually can see them. It doesn't do me much good to have cards on my screen that only I can see and cards on your screen that only you can see, and we never see each other's cards. Like, there's really no point in that. There might be some reasons for me to only see my cards for some time and you only see your cards for some time, and we'll get into that later. But right now I just want to see how I can get the cards to be generated by the server so that everyone can see them. So that's going to require me to do a couple of different things. The first one is I need to go into my code, and I go into my draw cards function. Remember, this was the one that's on our button. I actually want to move all of this over to a new script, which we'll call Player Manager. So let's create that now. Let's go to our Player Manager prefab, which has not much except for the network identity and transform attached to it. Let's add a new script. And let's call it Player Manager. Spell it correctly. And this is where a lot of the code is going to live that we are using. And I'm actually going to make sure that it's going to create this in my root directory for my assets folder. So I'm just going to move that to scripts because I like everything in one place. And then in the scripts folder, I open my Player Manager script. And it's got nothing in it, which is great. And I'm going to move a lot of this code over from my draw cards script. We're still going to keep the draw card script, but we're going to change it quite a bit. And the first thing I actually need to do is I need to add a new namespace to this because the standard Unity libraries aren't going to know anything about what I'm going to try to do here. So I'm going to say using mirror. And we mentioned at the beginning of the video that our scripts derive from mono behavior. we need to change this with any script that involves networking, and we're going to say that we're deriving from network behavior. And that if you're using the Unity tool set that comes with Visual Studio, if you've installed it, you will see that the autocomplete is great. It will just know that now that I'm using Mirror, I want to be deriving from network behavior. And I'm going to move a bunch of this stuff from the draw cards script, namely this this stuff here. I'm just going to Control X and paste it right here above the start function. What else am I going to do? I'm going to well, I'm going to use this this cards dot add as well, but I'm going to put it in a different place. And I'm going to use this on click, but I'm also going to put it in a different place. So let's just wait on that for a second. I'm just moving the functionality of this stuff over to my player manager. And I'm also going to expose a public game object called drop zone. And there's a couple of things that we can use right now, right off the bat from this script. For example, when I go to my player manager here in my prefabs folder, I have this player manager and I have card 1, card 2, player area, enemy area, and drop zone. The card 1 and card 2, that just these are these two cards. I can just drag and drop them here because these are the cards that I'm going to want to instantiate or to spawn when my game's ready. But the player area, enemy area, and drop zone, I'm not actually going to spawn them using the player manager. They're going to be created at runtime by the network manager. So I need to be able to find them similarly to the way that I found the canvas as we've done in a previous video when we were trying to find the main canvas during the card zoom event when we zoom in on a card. I think we actually also do it with the drag and drop method. So we're going to do that same here with the player manager. We're going to say that instead of the start function here, we're going to use one of the networking functions, which is called public void override on start client. And we're going to say here, I did this backwards, public override void on start client. It derives from, or it uses all the same stuff as the base's on start client. This just means that what we're doing here, we're saying that when the client starts, and there are different, there's a different flow that you can look at when you go to, I can't remember actually where this lives, on the network Mirror networking website, or if you go to one of these videos by First Gear Games, they give a really great in-depth explanation of, what's the video I'm looking for? Network behavior, the start cycle. It says what happens first. The server starts, and then the client starts, and then the local player starts, and then your normal start function starts, and then then it's awake, then it's start, or whatever. It lets you know what the start cycle is every time that a server starts or a client starts. What's the order of operations? And what we're doing here, we're saying instead of the start function, we're using on start client. When the client is started, we want you to do this thing. We want you to override the on start client that is already packaged with Mirror. We want to do everything that the on start client already does, but we want to override it by adding these specific things. We want to say that the player area is equal to GameObject.find and then a string called player area. So that just means find where's the player area. Find it for me and store it in this variable called player area. Enemy area equals GameObject.find enemy area. Find that as well. You'll remember that's been created by the server. And drop zone, find the drop zone that has been created by the the network manager. Find these things when the client starts. Now, this might throw you a little bit for a loop as we have to think in the minds of three different things. We have to think of the server, we have to think of the client that's on the server, and we have to think of the client that's not attached to the server, that it's a client only. And for the sake of these videos, we'll say that I'm going to be the host, I'm the server and a client, and you're a client. And I'm going to start a game, and you're going to attach yourself to that game and start communicating with the server that way. So, but all of this stuff lives in the same script. Like, I'm going to send you the same game as I'm playing here. It's just Mirror that's going to determine who's this, or we'll determine through Mirror who's the server or who's the host and who's going to be the client. So it might be confusing to see all of that in the same script, because you might say, well, the server should have a different script, and the clients should have different scripts, shouldn't they? And the answer is, well, kinda. But because we're using the same game, we're putting all of the code in one script, and then we're asking Mirror to determine what to do, whether or not what to do based on whether we're the host, whether we're a server and a client, meaning the host, or whether we're just a client. So when I do this here, when I put in brackets server, this means only the server is going to do this function. If I did client, that would mean only the client's going to do this, or only a client's going to do this. And for the server, I'm going to say public override void on start server should do this. Cards.add card1 and card2, which we've already established what those are. So the server is going to handle the creation of the cards. So we need to say, when the server starts, hey server, add these to your cards list. The client doesn't need to do that. And in fact, if you try and call onStartServer from within your client without this server tag, I think it throws you an error. I think I encountered that myself, so don't do that. Great. So now the server is going to handle managing the cards and what they the card list that we're going to draw from. We still have this onClick function that exists in on our button. That's now not going to work because we've deleted a bunch of stuff. So what we're going to create here is our first real network code that's actually going to be pretty fun. It's called command. We have to tag it with command, and we're going to say public void cmd deal cards. Create a function. Let's talk about this in great depth. If we think about the client-server relationship, forget about host for a minute. If I want the client to ask the server to do something, I need to use this word called command. If I am trying to do anything network related that the server needs to handle, but I'm asking from a client authority perspective, I will use a command to do that. When you're using a command, and it could be something as simple as change this number or update my position, or I don't know, you think of something. I'm going to use a command to do that. And with Mirror, I have to do two things here. I have to use this command tag in brackets up here. And if you hover over it, you can see call this from a client to run this function on the server. And I have to call it, I have to preface it with CMD, capital C, and then lowercase md, and then deal cards. Or whatever your function name is, it has to begin with CMD for it to be run correctly as a command. If I'm instead creating a function from the server that I want all clients to run, that's called a remote procedure call, or an RPC. We'll deal with that in a second. Just know right now that if I want the server to do something for me as a client, I have to run a command. And this command deal cards is going to be pretty much identical to the function that we have here, or the loop that we have in onClick. I'm just going to Control X and Control V this and paste it. And I'm saying for int I equals 0, I'm incrementing I up to 5. I have a game object called player card. I'm going to instantiate it. I'm going to set the parent to the player area, and I'm going to do the same for my enemy cards. Now, let's consider this. This worked when I was playing as a single player with a single game. But what's not going to work here is like half of this code. The reason why is I'm going to instantiate cards, but what that's going to do, and I don't think we need to look at it in this video, you can play with it yourself, is it's just going to instantiate a bunch of game objects in my game. It might not even do anything at all. At best, it will just instantiate it in my game, and it's not going to show in your game, which is the whole point of this exercise. Furthermore, it might set its parent as the player area transform, meaning that you might recall in an earlier video, we instantiated our player card, but it didn't show up anywhere on the screen because it was just instantiating here in the hierarchy, but it wasn't setting its parent to one of either the player area or the enemy area, so we couldn't see it. But this isn't going to do us much good here because it's going to set its parent on my screen where the card was instantiated, but it won't do it on your screen because your game hasn't been told to do that. So we need to come up with a solution to that, and I'll show you how we do that in a minute. The first thing we need to do here is, actually, we're just going to delete this whole enemy card thing because it's not going to be of much use to us, because your cards are going to be my enemy cards and my cards are going to be your enemy cards. So we'll just delete all this stuff. And we'll say, instead of calling this a player card, for ease's sake, let's just call this card. We're still going to instantiate it as a random range between between 0 and the length of our cards list. And we actually don't need a vector 3. You could leave it as you want, but we need a vector 2 because it's a 2D game. So leave that if you like. And then I have to change this reference to player card as just card.transform. I'm actually, you know what? I'm just going to delete all this stuff right here because I don't need it. I'm going to say I want to instantiate a player card, or 5 of them, in fact. And I'm going to say network server dot spawn card, comma, connection to client. And this is where we get to talk about authority. To spawn an object using mirror, which means I want the network server to create a card in everybody's client that everyone can see and potentially play with or work with, I first have to instantiate it, and then I spawn it. And I use network server.spawn and then whatever the object that I just instantiated. The second parameter here is connection to client. And this this allows me to determine that the authority for that object is going to come from the client itself. That just means that when I spawn a card from the network server, I might run into authority issues if I try and do something. Like, let's say I have a command on that card, which we'll see in a moment, that I want to run, and I want the server to run that command. Well, I might get an error because the server spawned that card, and now as a client, I'm trying to use that card to perform some work for me, to run a command for me, and the server might say, you don't have authority for that. I made that object for you. I spawned it for you, and I have authority over it. And so maybe the person who's playing as the host, who's the server and the client, might have authority over it, but the person who is just a client will not have authority over it, so you're not able to perform network actions with it. With this network.server.spawn, I'm spawning the card, and I'm saying assign the authority to the client that it's connected to. And in that way, it smooths the edges for me so that I have the proper authority when I'm trying to do something with that card that requires network actions. We'll see that in play. That's all well and good. In fact, let's just save this, and well, we need to attach it before we do anything. We need to attach it to the draw cards function. here in the draw cards script where we deleted everything, we need to do the same thing that we did in the player manager script. Let's say using mirror, and we need to derive from network behavior instead of mono behavior. We don't need the start function here, but what we do need to do is say public player manager. We're saying there's a script out there, or there's a class out there called player manager, and on click, instead of just dealing cards, we're going to say network identity is the type, and we're going to say little lowercase network identity is equal to the network client dot connection dot identity. Took me a long time to figure out how this works, so I'm just going to tell you that what we're doing here is when you start a client, that client has an identity, and we're saying we want to store that identity that is of that client's connection in this variable called network identity. And the player manager that we're looking for is equal to the network identity dot get component player manager. This is analogous to how we at runtime we say, hey, find that player area, or find that enemy area, find that drop zone. We're not able to drag and drop our player manager because it doesn't exist at the time before runtime. So we're saying in a similar way in our on click method on the button, which is called draw cards, we say find me that player manager that exists in my client that's attached to the network client connection. And when somebody clicks this button, run player manager dot cmd deal cards, which is this function, this command that we created here. Let's make sure that's still attached to our button, because on our button we changed, it doesn't know what the player manager is because it doesn't exist in our scene yet, remember. Yeah, so it's still great. We've done this correctly. So when somebody clicks, it should run drawcards.onClick, and the drawcards.onClick does everything that we just said. It finds the player manager through the network identity, and it hits command deal cards, which is this command over here. Remember, your command is a function that is run on the server by request of the client. There's another way of doing this that we might encounter, but for now, this will work for us. Sometimes you wrap this in another function, which is like, let's just call it deal cards. I'll show you. It'll be like deal cards, void deal cards. Well, it would have to be public, but whatever. And you would say if has authority, command deal cards. You might see that as well, just to make sure that the thing has authority before it tries to run a command, but we don't really need to do that right now. You just might encounter that in your adventures. Okay, saved everything, save the scene, hitting Control B to build, and we'll see what happens. I don't expect much from this, but I just want you to get used to the workflow when we're working through some of these things. And I'm happy to say that our draw cards method is complete, so we don't have to do anything with that. Okay, so my game's running. I'm going to use the built game as the host, and I'll go back into the editor and run this as a client. And now when I hit draw cards, nothing happens. And I hit draw cards, nothing happens. Perfect. That's actually exactly what we want. Nothing happens here in the build scene, in the built game, and nothing happens here in the editor scene, irrespective of whether or not they're the host or the client. But what we do see is that we have all these cards instantiated here on the side, and we're wondering, well, where do they go? I did all that work in the previous two videos to make sure that they were populated underneath these, the enemy area and the player area. Well, the fact of the matter is that when you instantiate them on the server, or when you spawn them from the server, we now need to tell each of the clients what to do with those cards. And for that, we're going to use a remote procedure call. Just close this window so that it doesn't bother me later. A remote procedure call, as you'll recall, is what we do when the server tells all clients to do a thing. It's kind of like the opposite of a command. And we're going to do that in a similar way as we've done before. And we're going to say with the command, and we're going to say, let me delete my update method. We're going to create a tag called client RPC, remote procedure call, and we're going to call it a void RPC show card, and it's going to take two parameters: game object card string type. Okay, so just like the command, I need to have a tag up here that's called client RPC. If I put my mouse over it, the server uses a remote procedure call RPC to run this function on clients. And just like a command, I need to have a little prefix here. Rather than CMD, it's RPC. So whatever your function name is, it has to start with RPC. And I'm passing it a game object, which is, we're calling it card, and a string, which is just going to be called type. We'll see why in a second. And we're going to say if type equals delt. Now we're going to run that check. If has authority card.transform.setParent player area transform false. Okay. Else card.transform.setParent enemy area transform false. Okay, what does it say? It says we're establishing a type of card, and we're saying if it's a card that's being dealt, then we go into the next level of this if statement. If the client that this player manager exists in is attached to, then if it has authority, meaning if it's my card, then go ahead and set its parent to the player area. And we, as you recall from the previous video, we've said false because we don't want it to keep its world position. We want it to have a new world position that is set to the parent world position. Or if it doesn't have authority, meaning if it's not my card, put it in the enemy area transform. That's where I want it to go. And we'll see what that looks like after we call this. So you'll recall in the command deal cards, we've said, hey server, deal me cards. And then we'll say, we'll call this right underneath that, and we'll say RPC show card, and we'll pass the card, and we'll say that it was just dealt. Okay, so when we click the button, we issue a command to the server from the client saying, deal me cards, please, and give me authority to them in my client. And then run this RPC show card. The server is told to run the RPC show card that says, go ahead and show all these cards, show this card on the client, and we do this 5 times. Show this card on all clients. If the client has authority, and you'll remember the cards that I'm dealt, I have authority over, they should be set to the player area. If I don't have authority over them, that means those are somebody else's cards. Set the transforms to the enemy area. Okay, no, I don't want that. I want this. Okay, let's save this and see if it works. Well, I'm going to hit Control B, and if you just want to see if it works on the host, you could very well just run play in the editor, select yourself as host, and run it. But I want to see if it works for both players right now. here I'm going to click LAN host. And in my editor, I'm going to hit play, and I'm going to select LAN client. Now the two clients are connected to one another. I'm going to hit draw cards here in my my server or my host, and I'm really happy to see that now they're appearing as they should on the bottom of my screen in my player area. And what's super cool and a really good feeling is that in my client, in the editor, I now see those exact same cards in my enemy area rather than in my player area. So check it out. I have 4 of the magenta pings and 1 of the blue pings, and I have the same thing in my my client. When I hit draw cards in my client, I get a different set of cards because you remember they're randomized, and I go back to my server, and voila, they're all here. Well, the gang's all here, folks. We have 2 pinks, 1 blue, 2 pinks, 2 pinks, 1 blue, and 2 pinks. That lets me know the networking is working. The cards that I have authority for are being displayed on my screen in the player area. The cards that my opponent has authority for are displayed in their own player area, but they're displayed in my enemy area, which is what I want. That's the functionality, and vice versa. Awesome. That's working. Give yourself a pat on the back because that's awesome. And it takes some thinking to do. Good. Okay. The next thing that I need to think about is, well, you'll recall, I shouldn't have closed that screen, but whatever. You'll recall that when I'm a host here, or if I'm a client, after I draw my cards, I can drag and drop stuff in my client. But I can tell you right now, this won't work in your in the other client. Like if I'm doing it in my editor, it won't work in the standalone version, in the built version, and vice versa, because I haven't told Mirror what I want to happen upon that case. So we need to deal with our drag and drop script. So what I'll do is I'll go into my drag drop script. You'll recall this is attached to all cards, and I need to change some things to make this work. Let's do that now. So I have a public game object, which is the canvas, and we find that main canvas on start. I now need to add also the drop zone because I didn't have to work with that in my single player game. Now that it's instantiated by the server, I need to find it. So I'm going to say public game object drop zone. And in my awake function, I'm actually going to change this to start because I've had a little bit of wonkiness when it comes to the awake and start function with that start cycle when your client starts and the server starts and all that. So just change this to start. And my canvas is going to equal to game object.find main canvas. The drop zone is going to be equal to game object.find drop zone. And before I do anything else, I also need to make sure that I add the namespace using mirror. And because we're doing networking stuff, I need to derive from network behavior. Okay. Now, we might run into some issues with authority here, because when we drag and drop cards on the screen and they appear in other people's screens, at least that's what we're about to do, we might run into the problem where I drag and drop a card on my screen. It appears in your screen, and you're able to drag and drop it as well. But then when you do that, things screw up because you don't have authority, and like the whole thing just goes bonkers. So we're gonna establish a check that determines whether or not I'm able to drag this thing by saying whether or not I have authority over it. So right in my these private Boolean declarations up here, I'm gonna call something. I'm gonna create something, declare a Boolean called private bool is draggable, and I'm going to equal that to true. That when this game object is instantiated, created for the first time, just set that to true. And in the start function, immediately I'm going to say if exclamation mark has authority, meaning if this client doesn't have authority, set is draggable to false. You'll notice if you look into the start cycle, there's like, I don't remember what the order is, but it's like on start server, on start authority, on start client, on start local player. There's a certain order of operations that we talked about, and there's a specific point where it's determined whether or not the object or the client or the player or whoever has authority, and your start function is going to occur after that. So we're saying, so by the time we get to our start function of this object, we know whether or not the client has authority over this object, and I'm saying if it doesn't have authority, just set is draggable to false, so I won't be able to drag it. Everything else stays the same here until we get to our start drag function. We'll get some errors if we don't do this. So I'm going to say if exclamation point is draggable, return. That just means if this thing is not draggable, like it doesn't have authority, for example, just don't do anything. Go back. And same in my endDrag function. I'm going to say if it's not draggable, return. Go back. Turn away from here. Otherwise, if it's draggable, go ahead and do what we're about to do. We're going to stay this. The rest of this stuff is going to stay the same. We just need to think that if I have authority over the object, which I should because it's been instantiated on my screen, then I'm going to be able to drag the card around the screen, and if I drop it over a drop zone, it should fall into the drop zone. When it falls into the drop zone, that's the key moment where I need to send an information to the server and say, hey server, card played, and I need you to replicate this on the other person's screen so that we all can see what just happened. You might have a different use case scenario. Maybe you want it to happen in your update method so everyone can see your card as you're dragging it around. I don't know. That's really up to you. But the base functionality we're working on here is that when the card is dropped, we should send a message to the server to replicate that on all clients. So I'm saying transform set parent to the drop zone, which is happening locally in my client. It's not happening anywhere else. I'm going to set is draggable to false, meaning that once I've played my card, no takebacks, I have to leave it there. And I'm going to find the network identity just as I did in my my draw card script, and I'm going to say network identity lowercase network or camel case network identity is equal to the network client dot connection dot identity. Find me the network identity that exists on the client, the client connection in my client, remember, and I'm going to say the player manager is equal to network identity dot get component player manager. So find my player manager next to the find my player manager that is in the client that I'm working on right now. And I realize that I haven't declared my player manager. I need to do that up here. I'm calling this a public player manager, and I'm calling it player manager because it's a script. It's a class. It's not the game object that the player manager is attached to. I want to work with the class itself. Just call this player manager. Okay, now I can work with it down here. So I found the player manager, and I say player manager dot play card game object, not big case, lowercase. Okay, I haven't created this play card function yet. I'm just saying when I drop the card, run this this function or method on the player manager attached to the client that I'm working on, and pass in this particular, when I say just game object, that means this game object. the drag drop is attached to script is attached to a card, and I'm saying, well, pass this card up the chain because you're going to need this. Now I need to create that card in my function in my script in my player manager. So I go over to my player manager, and I'm going to create a new function. Let's do it under this command deal cards, and it's going to be called. Let's do it this way that I mentioned before: public void play card game object card. Oops, don't need all that. We're doing this a little bit differently, and we'll see why in the next video. We're just doing a little bit of setup to make things easier on us later. And in play card, all I'm going to do is I'm going to run another command called command play card, and I'm going to pass in that same card. Let's follow me for just a second, and then we'll get there in a moment. Underneath, I'm going to create a command called public void. Oh, actually, I don't think this needs to be public. We can just call it void command play card and pass to it the parameter of a card, which is a game object. And in it, we're going to call RPC show card. Okay, before we go any further, let's explain what we're doing here. When I drop the card, I find through the network identity, I find the player manager that is in my client, and when I drop the card, I say I want you to run play card from the player manager, and I'm passing to you the game object, the card that this script is attached to. When player manager receives that request, play card, it receives the game object, which is card. It is then going to run command play card, similar to our command deal cards here, but we've wrapped that in kind of like a helper function that's going to do more work for us in the next video. That command play card is set up very similarly to the command deal cards function, but it's private because only this script needs to see it. And it takes the game object card, and all it's going to do when it receives command play card, it's going to use the RPC, the remote procedure call that we've already created, RPC show card, and it's going to pass to it the card that's it's just been moved from the drag drop function to the play card function, and then now to the command play card function. It's passing that same information to RPC show card, and it's saying that it's also adding the string that this card has been played rather than been dealt. In RPC show card, we need to just add a little bit of logic. We've said if the type of the card is that it's just been dealt, do this stuff. And we're saying else if the type of the card is equal to equal played, we'll say card.transform.setParent dropzone.transform. And again, we'll set that to false because we want it to take the drop zone's location. And that's it. That's it for now. We're good to go on that. So if I say if I look at my card drag drop script, I've asked the player manager to run play card with this game object attached to it, and then the play card function passes that information to command play card, and then command play card commands or asks the server to then it gives the information of what card was just played, and it says, okay, now use RPC show card to get every client to show the card that was just played by setting its parent to the drop zone within that client. Now I have saved everything. I'm going to build it. Take a little while to build. As it does that, I'm going to hit play here in my editor. I'm going to start out as a host on my built game and as a client on my editor. I hit draw cards. I see the same functionality here where my player cards are here, or let's say this is you. These are your cards. they appear as these cards on my screen, and then I hit draw cards on my screen, and they appear on your screen just fine. Great. Now I'm going to draw a card from my player area onto the drop zone. It drops in the drop zone, and it appears in your drop zone. Whereas I'm trying, you can't really tell, but I'm trying to drag my cards from your screen, from the opponent area, and I can't do that, nor can I do that here when I'm drawing them from your cards, because I don't have authority over those cards. You have authority over your cards, I have authority over my cards, and nobody's able to move anything once the card is dropped, because we did that little check that we said when the card's dropped, just make is draggable false. So I did that. Now you drag your card and drop it, and it shows up on my screen. I drag a pink card. There's another pink card there. You drag a blue card, and it's working great. That's exactly the type of functionality that we want to have. And if you have other things that you want to happen when your card is dragged and dropped, that's what you would do. So there's a few things to iron out here. For example, let's say that I want my cards. I don't want you to be able to see my cards when they're dealt to me, and I don't want to be able to see your cards. Well, maybe I do want to see your cards, but that would be cheating. You don't want me to see your cards when they're dealt. So instead, we want to have card backs, and maybe there's also some other information that we want to sync. I think that's pretty good for this video. So let's continue in the next episode of creating a 2D card game with Unity, and we'll pick up right here, right where we left off. So expect that, and I'll actually link that at the end of this video. I hope this has been helpful for you. If it has, please be sure to like it and subscribe to my videos for more. You can also follow me on Twitter and check out my books and games, and we'll see you soon. Thanks for watching.